Hello, today I'll be talking a few rule of thumb for electron beam therapy. So the first one is R90, the range is E by 3. E is the energy of the electrons. Okay, example like from a surface of skin, if you want to treat at a depth of 2 centimeter, then what energy of electrons will you use? Okay, so the energy of electrons that you will use is E by 3 equals to 2, 3 into 2, E equals 6 MeV. The energy of electrons that you will use to treat at a depth of 2 centimeter is 6 MeV. Alright. The second point is the stopping power. So every centimeter of the distance that the electron travels, it loses 2 MeV of its energy. So 2 MeV is lost per centimeter. Okay, for example, if it is a 6 MeV electron beam, then at a depth of 1 centimeter the energy would be 4 MeV, and on another depth of 1 centimeter, that is 2 centimeter, the energy would be 2 MeV. Then at a depth of 3 centimeter, that is another centimeter, it will finally come to stop, that is 0 MeV. So the distance that it travels is 3 centimeters. So 2 MeV is lost per centimeter. Alright. The third point is, if you have to treat some lesion, okay, but there is a critical structure near it, for example there is an eye, there is an eye near to the structure, then you need to use a shield, lead shield. Okay, so what thickness of lead shield will you use? Okay, so the third rule of thumb is, for every 2 MeV of electron energy, you need 1 mm thickness of lead. Alright, so if I am using a 4 MeV electron beam, okay, to treat at a depth of 2 centimeter, okay, then you will need 2 mm thickness of lead. Alright, so that's the third rule of thumb. Now some modifications to these, they will twist the questions, and like the scenario can be twisted. For example, this is only in soft tissue or water. Okay, they will so if there is a skin tissue, there is a soft tissue over here and there is a lung underlying it. Okay, then what would be the distance of the electron beam traveling? So you need to understand that the density of the lung is different, so it is the density of the bone is also different. All right, so the underlying tissue can be a lung, can be bone. So the density over here is 0.25, here it is 1.5. These are some of the values that you have to remember. Alright, this is 1.5. So in a soft tissue or water, if the electron beam travels 1 centimeter, then what would be the distance it travels in lung? It will be 1 divided by 0.25, that is 4. So if it travels 1 centimeter in soft tissue, then it travels 4 centimeter in lung. Okay, the same energy. Okay, for example, it is 2 MeV. Okay, it travels 4 centimeters in lung, and in bone it is 1 divided by 1.5, that is 0.6. It travels lesser than it travels in the soft tissue. All right. So these are few rule of thumbs that you have to remember for electron beam therapy.